laboratory preparation, properties. In this lesson, we will discuss the isolation of nitrogen from air, laboratory preparation, properties and uses. Facts about nitrogen. Nitrogen is one of the most familiar substances on Earth. It makes up 78% of air that surrounds us. Nitrogen is found in combined form in a few mineral compounds, for example, proteins that all animals use as food to build up tissues. Nitrogen products are among the most important chemicals produced in the world today. The largest quantities are used as fertilizers. The following animation shows how nitrogen is isolated from air. Study it carefully and answer the questions that follow. Nitrogen is obtained by first passing air through concentrated potassium hydroxide solution to absorb carbon-4 oxide. Oxygen is removed by passing the residual air over heated copper tannings. The remaining part of air is mainly nitrogen with traces of noble gases. The following video clip shows how nitrogen is prepared in the laboratory.
In preparation of nitrogen gas, the following apparatus and reagents are to be used: a round bottom flask, a pair of tongs, a gas jar, a boiling tube, a delivery tube, a thistle funnel, and a cork, a water trough, a Bunsen burner, a clamp and stand, sodium nitrate, ammonium chloride, and calcium hydroxide solution, a wooden splint, magnesium ribbon, litmus paper, and matchbox containing matchsticks.
Procedure: mix 7 grams of sodium nitrate with 5.5 grams of ammonium chloride. Place the mixture in a round bottom flask. And add 150 centimeters cubed of water. Clamp the ground bottom flask on a stand in a slanting position. Place a boiling tube full of water on a beehive shelf. Heat the mixture in the round bottom flask and allow a few bubbles to escape to drive air out of the apparatus.
Nitrogen gas is prepared by heating a mixture of ammonium chloride and sodium nitrite to form ammonium nitrite and sodium chloride. Ammonium nitrite is unstable and decomposes to form nitrogen and steam. Nitrogen gas is generally unreactive under ordinary conditions. However, at higher temperatures, it reacts with metals in group 1 and group 2 to form their nitrides. Nitrogen gas is generally unreactive under ordinary conditions. However, at higher temperatures, it reacts with metals in group 1 and group 2 to form their nitrides. When some water is added to the magnesium nitride, ammonia gas and magnesium hydroxide are formed. The following are some of the uses of nitrogen gas. In this lesson, we will discuss the laboratory preparation of nitrogen 4 oxide, its properties and uses. Nitrogen 4 oxide is a poisonous gas. This experiment should be performed in a fume chamber or in open space.
The following experiment
When concentrated nitric acid is added to copper tannings, red-brown fumes of nitrogen 4 oxide are immediately observed. These fumes fill the flask and the gas jar. A green solution of copper 2 nitrate is left in the flask. Step 1. Place lead 2 nitrate in a boiling tube. Step 2. Clamp the boiling tube in a slanting position. Step 3. Connect the delivery tube from the boiling tube to the U-tube in a trough of ice-cold water. Step 4. Heat the boiling tube. When lead 2 is heated, it decomposes to form lead 2 oxide, nitrogen 4 oxide and oxygen. Nitrogen 4 oxide condenses to form dinitrogen tetraoxide. This is a pale yellow liquid. Oxygen is collected over water. It is a red-brown gas. It has an irritating smell. It is denser than air. It is soluble in water. The following video clip shows some of the properties of nitrogen 4 oxide. Observe what happens carefully.
Add 10 cubic centimeters of water into a gas jar containing nitrogen 4 oxide gas. Shake well and place blue and red litmus paper. Note what happens.
The following video clip shows what happens when burning magnesium ribbon is inserted into a gas jar.
Cut a piece of magnesium ribbon. Hold it using a pair of tongs and light it. Dip the burning magnesium ribbon into a gas jar containing nitrogen 4 oxide gas. Observe what happens.
The red-brown gas turns colorless. White specks of magnesium oxides are formed. Conclusion: Burning magnesium continues to burn in nitrogen 4 oxide, forming magnesium oxide and nitrogen gas. The heat from burning magnesium decomposes nitrogen 4 oxide to nitrogen and oxygen gas. This oxygen supports the burning of magnesium. Nitrogen 4 oxide oxidizes red-hot copper while it is reduced to nitrogen. It also reacts vigorously with burning phosphorus oxide and sulfur 4 oxide respectively. In this lesson, we will discuss preparation, properties and uses of nitric acid. Nitric acid is prepared in the laboratory by the action of concentrated sulfuric acid on metal nitrates. Concentrated sulfuric acid and potassium nitrate are commonly used. Nitric acid is manufactured by the catalytic oxidation of ammonia. Ammonia is obtained through the Haber process. The catalyst used is platinum rhodium gauze. The raw materials required are ammonia, air and water. The flowchart shown illustrates the Ostwald process. Step 1. The air or ammonia must be free of dust and other impurities to avoid poisoning the catalyst. Ammonia is oxidized to produce nitrogen 2 oxide and water. The heat produced in this step maintains the platinum rhodium catalyst temperature at 850 degrees Celsius to 900 degrees Celsius and therefore no further heating is required. Step 3. Nitrogen 2 oxide and steam are cooled by air from the compressor. Nitrogen 2 oxide is oxidized further by the air to produce nitrogen 4 oxide. Step 4. Nitrogen 4 oxide is then passed through water to form nitric acid. Step 5. About 65% nitric acid and 35% of water are produced from a single converter. The unreacted air, ammonia, and nitrogen 4 oxide are recirculated back to the compressor. The concentration of the nitric produced can be increased by distillation. The following tests were carried out using dilute nitric acid. 1. Add dilute nitric acid to blue litmus paper in a test tube. 2. Add dilute nitric acid to zinc powder in a test tube. 3. Add dilute nitric acid to copper 2 oxide in a test tube. 4. Add dilute nitric acid to phenolphthalein indicator in a test tube. In all these reactions, nitric acid is reduced to either nitrogen 2 oxide or nitrogen 4 oxide and water. This shows that concentrated nitric acid is a very powerful oxidizing agent. Its oxidizing power depends on the concentration, temperature, and type of reactions. Dilute nitric acid ionizes in water to produce hydrogen ions and therefore acts as an acid. In all these reactions, nitric acid is reduced to either nitrogen 2 oxide or nitrogen 4 oxide and water. This shows that concentrated nitric acid is a very powerful oxidizing agent. Its oxidizing power depends on the concentration, temperature, and type of reactions. Nitric acid is used in the following: The word pollution comes from the Latin word polluere, which means contamination of any feature of the environment. The figure below shows the sources of nitrogen oxides and their effects on the environment. These are environmental laws that ensure that all chemical waste from industrial process are disposed in a manner that minimizes harm to the environment. One way of disposing chemical waste is to recycle them and reuse them for other purposes. In this lesson, we will discuss the preparation of ammonia in the laboratory and large-scale manufacture of ammonia. The following video clip shows the preparation of ammonia gas. Click to play the video and observe carefully what happens.
Place a small amount of ammonium chloride and calcium hydroxide in a mortar. Grind the mixture using a pestle and place it in a round bottom flask. Heat the mixture in the round bottom flask, clamped at a sloping position. Place a moist, red litmus paper at the mouth of the gas jar and note the observations. But it's time in a change. So it's supposed to change red litmus paper blue.
Ammonia gas is usually prepared in the laboratory using an ammonium salt and a base. The gas is collected by upward delivery because it is lighter than air. Calcium oxide is used as drying agent in preparation of ammonia gas. Usual drying agents such as anhydrous calcium chloride and concentrated sulfuric acid are never used in drying ammonia gas. This is because they react with ammonia gas to form calcium chloride, ammonia, and ammonium sulfate. Ammonia gas has a pungent choking smell, is colorless, and is very soluble in water. Reaction of ammonia with water.
The following video clip demonstrates the fountain experiment. This setup is for the collection of ammonia gas in a round bottom flask.
Moisture mingi sana.
Kuna mingi? Na sasa inatoka wapi? Oh, because of the cooling. What has happened? The following apparatus are used in the fountain experiment. Ammonia gas is very soluble in water. This is why it gives the fountain experiment. In the fountain experiment, the ammonia in the flask dissolves rapidly in the water, creating a partial vacuum. The water making the solution rises to occupy the vacuum. This causes the fountain. Ammonia gas reacts with water to form ammonium hydroxide solution, also called ammonia solution. Ammonium hydroxide solution dissociates in water to form ammonium ions and hydroxyl ions. The hydroxyl ions give the solutions its basic nature. Hence, red litmus paper dipped into the solution turns blue. The following video clips shows the reaction of ammonia solutions with metallic halides.
The following experiment is used to test for various ions using ammonia solution. In this experiment, the following apparatus and reagents are used: a test tube rack with test tubes, a beaker and a dropper, magnesium ions, and finally, ammonia solution. Place 2 milliliters of magnesium sulfate solution in a test tube. Add 2 drops of ammonia solution and shake for about 30 seconds. Add excess ammonia and observe what happens.
The following video clip shows the reaction of ammonia solutions with zinc ions. Click to play the video and observe what happens.
The following experiment is used to test for various ions using ammonia solution. In this experiment, the following apparatus and reagents are used: a test tube rack with test tubes, a beaker and a dropper, zinc ions, and finally, ammonia solution. Add ammonia solution to the mixture until in excess. Observe what happens.
The following video clip shows the reaction of ammonia solutions with lead ions.
The following experiment is used to test for various ions using ammonia solution. Add ammonia solution until in excess. Observe what happens.
The following video clip shows the reaction of ammonia solutions with calcium ions.
The following experiment is used to test for various ions using ammonia solution. In this experiment, the following apparatus and reagents are used. Add ammonia solution until in excess. Observe what happens.
The following video clip shows the reaction of ammonia solutions with copper ions. Click to play the video and observe what happens. The following video clip shows the reaction of ammonia solutions with copper ions. Click to play the video and observe what happens. The hydroxide ions in ammonia solution reacts with metal ions in the table to form insoluble hydroxides. Magnesium ions dissolve in ammonia solution to form a precipitate of magnesium hydroxide. On addition of excess ammonia to zinc precipitate and copper precipitate, they dissolve to form complex ions. The complex ions are tetraamine zinc 2 ion and tetraamine copper 2 ions. What happens when a burning flame is introduced into a gas jar containing ammonia gas? How does ammonia react with air in the presence of heated platinum wire? Ammonia gas reacts with oxygen in the presence of heated platinum wire, which is a catalyst, to form nitrogen 2 oxide. Nitrogen 2 oxide is further oxidized to form red-brown fumes of nitrogen 4 oxide. Heated platinum acts as a catalyst in the experiment and continues to glow as the experiment proceeds. The following animation shows the reaction that takes place when ammonia gas reacts with copper 2 oxide. Observe what happens carefully. Ammonia gas is manufactured on a large scale using the Haber process with iron metal as a catalyst when mixed with aluminium oxide. Raw materials. Nitrogen gas is obtained from air by fractional distillation of liquid air. Hydrogen gas is obtained from natural gas, which is methane or crude oil. Step 1. A mixture of nitrogen and hydrogen are purified to remove dust particles which would poison the catalyst and reacted in the ratio 1:3 by volume. A high pressure of 350 to 500 atmospheres gives a high yield. This pressure is described as optimum pressure. A temperature of about 400 degrees Celsius to 500 degrees Celsius is required to give a reasonable yield of ammonia. This temperature is described as optimum temperature. Note that low temperatures are required to give the highest yield of ammonia. However, at a low temperature, the rate of reaction is low. Step 4. To increase the rate of reaction, iron is used as a catalyst. The catalyst is mixed with aluminium oxide to increase its efficiency. A substance such as aluminium oxide, which increases the efficiency of a catalyst, is called a promoter.